In this video, I'm going to show you how to properly use layered materials for Vertex painting inside Unreal Engine 5. Before we begin, we need to set up some preparation work. First, open Maya. Click the top left menu to create a plane, then press F to frame the model. Since Vertex painting in Unreal depends on the number of vertices on a mesh, I'll need to add more subdivisions to this plane. Click the small icon in the upper right corner of Maya's interface, go to Inputs, and I set both subdivisions values to 20. Now we have enough vertices. Press R to switch to scale mode and drag with the left mouse button to enlarge the mesh. Press E to switch to rotation mode. While holding J, the mesh will snap by 30 degrees each time you rotate. Check the UV to make sure they're laid out properly. This gives us a plane suitable for Vertex painting. The same rule applies to other meshes. The more vertices they have, the better the paint resolution will be. Next, select the plane, then go to File, click Game Exporter. Switch from Export All to Export Selection. Choose your export location, give it a name. I'll just call it SM_plane, then press Enter and click Export. Now, let's move into Unreal Engine. Open the Epic Games Launcher, log into your account, and at the top, click Library. Here I'm using UE5.5.4, but you can choose whichever version you want and hit Launch. Unreal provides many project templates. I usually pick one under Games that fits my needs. After selecting, choose a Save Location at the bottom, give the project a name, and hit Create. For this demo, I'll be using my pre-made tutorial project. Okay, once we're inside Unreal, let's start by creating a new level. Go to File, New Level, and select Basic. Now drag in the plane we exported earlier. In the Import window, uncheck Import Material under the Materials section, and also uncheck Import Textures. We don't need those. Click Import. To make sure our mesh supports Vertex paint, go to the Details panel, search for Nanite, uncheck Enable Nanite Support, and click Apply Changes. This step is important because Nanite is not compatible with mesh paint. Next, we need some materials. For this demonstration, I downloaded 3 free material from Fab, but you can use your own textures as well. Now I will drag the plane into the scene. Just like in Maya, the W, E, and R keys are for Move, Rotate, and Scale. Use right-click plus WASD to navigate the viewport. If the default icons are distracting, press G to toggle game mode. They will be hidden, and pressing G again brings them back. To duplicate the mesh, hold Alt and drag. I will assign my 3 chosen materials by dragging them onto the meshes just to preview what we will be using. The first one is a rough ground material. Next is a cleaner asphalt. The third one is a sandy dirt surface. Okay, that's all the textures I need. Now let us get to the main part, setting them up in a material layer system. In the content browser, right-click. Go to Material, Layers, and then Material Layer. I name it ML_layer01 and double-click to open it. Inside the graph, click the Set Material Attributes node in the middle. On the left side, click the plus icon to add texture inputs. You can add more depending on what you need. I do not need specular, so I can click it and replace it with ambient occlusion. I also switched anisotropy to normal. Now we have all the channels we need. For the first layer, I want a clean asphalt road material as the base. So I get into the texture folder, select all these textures, and drag them into the graph. Let's connect them to the correct pin. Put RGB from base color texture to the base color, of course. Then connect the ORM channels to ambient occlusion, roughness, and metallic. Finally, connect the normal map. Now we have the first material layer. Let's click the save icon. Back in the content browser, press Ctrl D to duplicate as the second material layer. In the second layer, I will swap the textures for a sandy road material. Click the texture sample, then drag the new texture onto it to replace it. I created the third material layer the same way, and in practice, you can add as many layers as you need. With all 3 layers ready, let's right-click the empty space and create a new material. I name it M_layer materials. Open it, you'll see many default input pins. We don't need those. So click the main node and go to the left panel, enable use material attributes. Next, right-click in the graph, search for material attribute layers and add that node. Connect it to the material output. On the left in Layers, Background, choose layer 01 I created as the base layer. Then save it. Now right-click on the material and choose Create Material Instance. And name it. Inside the instance, you'll see layer 01 already assigned. Click the plus icon to add more layers. Then choose layer 02 and layer 03. Save it. But to make blending possible, we also need a blend asset. So right-click, go to Material, Layers, create a new material layer blend. Inside, add a Vertex color node and an append vector node. Connect A to the first channel of Vertex color and B to the last channel. Feed the output into a channel mask parameter. Rename this parameter Vertex color so we can control it inside the material instance. Finally, connect it to the alpha input. Save it. Go back to the material instance and, under Blend Assets, assign the blend we just created. In vector parameter values, check the box for Vertex color. For blending order, I'll assign green to layer 02 and blue to layer 03. Layer 01 stays as the background. Let's test if it works. I duplicate a plane and apply the layered material. In the top left of the viewport, switch to Mesh Paint mode. Click Paint, change the paint color, paint on the mesh, and it works. Now, when I paint away the top layer, you can see layer 01 underneath. Adjusting the brush size shows how layer 02 blends smoothly between them. By painting only on the green channel, we reveal layer 02 directly. This method lets us blend multiple materials seamlessly. It's extremely useful for environment art, especially for grounds and walls. By mixing and blending textures, you can add rich detail and even storytelling elements to your scenes efficiently. Thanks for watching. Hope you enjoyed this video. If you'd like more tutorials, feel free to subscribe to our YouTube channel.